Hi everyone, Brightbone here, back with another video, and today I want to talk about ransomware, and specifically a ransomware type that I've seen recently affecting vSphere or ESXi hosts. Now, I set out to find some samples of ransomware to detect them, right? And I didn't find anything really readily available. There just wasn't a lot of samples out there. So I thought to myself, all right, this can't be that hard. I'll write my own. I've written ransomware before, wrote some in PowerShell, but this time I set out to write one in Python specifically for ESXi. This was incredibly simple and mind-blowing how easy it was to get this working in very few lines of code. So before I show you that, I want to talk about the pieces that are necessary to make this code work. The first thing you have to do is you have to power off all the VMs, right? Because you can't encrypt a running VM. Then once you've powered off all the VMs, you need to get a list of all the VMDK files. You then need to be able to create some form of key or embed a key in the ransomware. And then you need to find and encrypt all of the VMDK files. The VMDK files are the VMware disk files. Then you need to go and delete all of the old VMDK files that you have encrypted, that you've already encrypted and renamed, right? So those are typical ransomware steps. Any kind of ransomware, that's what it does. There's that mass file deletion at the end that you can detect. There is the encryption that you can detect. So there's a lot of different pieces. But the very first thing I want to show you is how to power off VMs from the command line. So I have my nested ESXi server here. This is ESXi 8, the newest version. And I have two VMs running. I have Ubuntu 1 and Ubuntu 2. Now this is nested, so I don't have a lot of VMs running here just because it's cumbersome to get them going. But I also have SSH turned on. Now, in a lot of environments, you'll find SSH on the ESXi host by mistake. You should not run this open. Absolutely not. And as a matter of fact, you should run lockdown mode. There is no reason that a web page or an SSH prompt should be presented to an end user in any way when it comes to ESXi. There's just no reason for it. If you have vCenter, log into vCenter. Control everything from vCenter. Do yourself a favor here. If you leave these things open and an attacker like myself can brute force, then we can do very, very bad things to your ESXi servers. So I have SSH open, and then I've also got my SSH command line over here, and I have logged in via SSH to the host. So if I do a simple ls, I can see things on the system. I can see my VMFS share over here. That's typically where the data stores are, and we'll go into that a little bit more in a minute. But first thing we need to do when writing ransomware is power off VMs, right? We need to be able to power off a VM. Well, that's quite simple, and there's two methods to do it, and you should detect them both. The first one is VMCMD. VMCMD. So if you're using VMCMD and VM at service power.off, and then you give it a number of the VM, you can determine, first off, what the VMs are by their number using VMCMD. Then you get Vim SVC power off to power them off. Once you've powered them off, you can then encrypt them. So I'm going to power off VM3 here, which is Ubuntu 1. We'll go ahead and power it off. It says powering off VM. Come back over here to our VM. You'll see now Ubuntu 1 powered off. So that's pretty simple, right? If I can write code to loop over all of the VMs and power them off, I've got my first step for my ransomware. Power off all the VMs. Now there's another method to do this that you want to watch for and you want to alert on. And that is the ESX CLI method. So if we do ESX CLI, and it's VM process kill actually. So first we'll do process list. This shows you the world IDs. You need the world ID, so you copy this out. In our case, 274.158 here. So copy this out. And then what we do is we do the process kill command, and then we're going to type force, because this forces it to power down. And then we'll give it the world ID. So world ID equals R. And I think in 8, this is actually double dashes. So let me do that. I'll do double dashes here. And this will probably kill off our second VM. And it did. So if we come back into our ESXi host now, Ubuntu 2, powered off. So if you see any of those power off methods, either ESXi method with force or the VimCMD method, you need to have a SIEM alert for that. Now I've set one of those up already. If we come over here to alerts and I refresh, we should have some alerts. And you can see we have abnormal VM power off. So if I take a look here at abnormal VM power off, we'll go to our table, go to our query, and our query is type ESXi and message ESXCLI VM process kill with the force or VimCMD Vim service power off. So if we go back over here to Kibana and we do the search, we just do this. That is a different one, but this one right here. And we can see here is ESXCLI VM process kill type force. And there's VimCMD VM SVC power off. So you need to be looking for these things. This is the precursor to ransomware in almost any variant that I've seen in the deeper work that I've done. It is very common that this is the first step, one of these two. Now there are other methods. You know, somebody can log into the GUI and force them all off. But these are easy to use and easy to script. So that's what happens. They power them off one of these two ways. So the second thing you want to have done when you're writing ransomware for ESXi is once they're powered off, you need to then get a list of the VMDK files. So if we take a look over here, we'll go into VMFS and we go into volumes. And then you'll see over here the alias for data store. And then you'll see my VMs here, Ubuntu and Ubuntu 2. So if I cd into Ubuntu, here is a VMDK file right here, Ubuntu VMDK and Ubuntu flat VMDK. These are what you're looking for. So you want to find these. You want to be able to find these in a programmatic way. Well, it's quite easy to do so, and you can do it basically from any directory. So I'll cd back out to where I was, back where my ransomware is. And clear screen, and you just do find /, and then you're going to look, you're going to grep for .vmdk. VMDK, just like that. And there we go. You have a list now of all of the VMDK files. I've got my list of VMDK files now. So once I have my list of VMDK files, now I can do keying, right? Now the crazy thing here is that ESXi has a Python interpreter and OpenSSL built in. So I don't even have to load any code to encrypt anything. I can encrypt the stuff with OpenSSL. I can generate a key and I can use the functions of OpenSSL to encrypt that file, and then I just exfiltrate my key and delete it, right? So that's the step we take. And then the final step is just deleting the VMs, right? That's easy, rm-f, and then give it the list of VMs. So now that I've shown you kind of the commands you need, I'll show you the ransomware. So we'll go ahead, we'll cat out ransom.py. And you can see what I have here is I have just a if not in vm.txt. It creates a text file on first run. That way if I run it again, you know, I don't have to worry about it. It will try with OpenVM text Z, and it's going to read the lines out of that file. So I'm finding all the VMs, I'm doing vimcmd VM servers get all VMs. That gives me those numbers that I was using with vimcmd to power it off. Then I do for line and line cmd vimcmd VM svc power off, like you saw earlier. I'm powering off all the VMs in a for loop. Then if there's an exception, I'm printing VMs are not powered off. The next thing I'm doing is just simply OpenSSL create a random base 64 1024-bit key and drop it in key.bin, which I then use as the encryption key. Then I'm opening the VMDK text that I created by doing the find vmfs grep VMDK. So I'm basically finding all the VMDK files, and then I am doing a for loop across those. Splitting some text up, throwing it through OpenSSL. Notice I'm throwing this in to here using the base and adding the crypt part to the end. So I'm taking the name of the VMDK file, taking off VMDK and putting .crypt there. And then I'm using the pass file that is the key bin here. I created a key on base 64 1024 key bin, right? So I'm using that as a file. I am then opening the VMDK text that I created. I'm going through and I am deleting all of the lines that are the VMDK files. Now notice in here I have a block to delete to stop the VMDK files from deleting. So I'm going to go ahead and just run this as it would normally run, deleting all the VMDK files, encrypting everything, and I'm going to pause the video once I start it because it takes quite a while for the ransomware to run, and I'll restart the video at that point. So I'll go ahead and start it. Actually, let me edit it real quick. We'll go pi ransom, pi.ransom.pi. We'll pull out the RMRF. This is going to actually delete the VMDK files, but I have an encrypted version of them, so it'll be fine. And I have the key, so I can decrypt them. And then we'll right quit here. And then we'll go Python ransom.py. And there we go. I'm going to let that go. And you see it's powering off the VMs. And here we go. It's doing OpenSSL. And this is going to take a little bit. So I'm going to pause the video and I will come back once it's complete. All right, and we're back. So the ransomware has run. It ran through, it encrypted all of the files with OpenSSL. It did throw an error at one point, and then it deleted all the VMDK files after that. So we saw the VMDK files delete here. And now when we take a look at our ESXi nested over here, and we look through our VMDKs, we see ubuntu.crypt, ubuntu flat.crypt, and no VMDK file, right? So it deleted the VMDK file. It also created the crypt file and the flat crypt file. So these are what you would need to take your key and decrypt if you were going to write this on your own. But working ransomware from a very simple Python script. And so what we want to be able to do, though, is detect these things. So earlier we detected our abnormal VM power off, right? So there's some other rules that I created for this. So if we look at abnormal VMDK file deletion, we'll see anything type ESXi and message remove and message VMDK. So we look over here and we do our query, go back over here to discover. Paste this in real quick. And you can see probably last 15 minutes or so, or my query is broken. Oh, I think that's a KQL query, and I'm in Lucene. That's what it is. Paste that in. No, that is actually Lucene. Okay, so we're looking for anything with a remove and a star.vmdk. This should show up unless my syslog is broken. And it's not showing up. Let me see if it shows up under logs. Nope. So this one's being strange, but this is the rule you would create. You'd be looking for type ESXi and the message field of .remove or rm-f and anything with a VMDK extension. Let me see if I remove this and if it will find it. There we go. Let's see if it's in here. Not looking like it, but this worked earlier. Essentially, you're just looking for anything removing the VMDKs. You don't want something removing the VMDKs in your environment through this method. Now, one other rule I suggest you create. So I'm going to clear the screen here. There's another method of doing persistence within VMware now. It's using the vib method or installing VMware supported software, right? So if you do ESX CLI vib list, this is going to show you, ESX CLI vib ESX CLI software vib list. This is going to show you all of the software that's installed on the system. And you can see these different pieces of software that are installed. And notice they say VMware certified here, right? Well, sometimes you'll see partner certified. Now, there's a way for bad guys to get around this by using the force command when they do a vib install. So if we do I'll just do a fake one here. So if I do ESX CLI software vib install, and usually you'd give it a URL or something like that. So we'll do vib URL, vib URL. I'll just give it blah.com. And then we do force. This would be the normal method that someone could use to install a vib on your system. Installing a vib gives them persistence. So you can do this method, and of course they'll go out here and try to install the software if it existed. And it says, of course, this doesn't work. But we want to make sure that we have a rule in our SIEM to fire on anybody doing the vib install with the force method. This is very abnormal. You shouldn't have to force it. It should be partner or VMware certified, no matter what. So if we come over here to our Elastic SIEM now, we should have another alert fire from that. And something must be going on with my rules engine, or it's taking a minute. We'll take a look at the rule. So we want, where are we? We want abnormal VMware vib software installation. So we'll go type ESXi and message, and we're looking for all of these different pieces in the ESX CLI. So we'll pull this guy out, drop this one in. Oh, that's strange how that went that way. But there we go. We can see ESXi software, vib install, vib URL, blah.com, and force. So if you ever see a vib URL force, you want to make sure that you are aware that that is happening. So that's basically all I have for today. Protect your ESXi host, protect your VMware hosts. This is an area that's often overlooked. There's no EDR here. And bad guys are starting to take advantage of this. And you saw how simple it was for me to write simple ransomware that would work on the system and encrypted everything up, deleted the VMDK files. So please, please, please take a look at this, because if you don't, now the bad guys are going to get you eventually this method. We've had several different organizations that I'm involved with have been infected with ransomware. When they got infected with ransomware, they did this type of tactic. They infected the VMware ESXi host, encrypted up the VMDK files where they could, and made a big mess of things. It's much harder to recover an encrypted ESXi host than, in some cases, a encrypted Windows host. So that's all I've got for you today. Thank you very much, and hack the planet to defend better. Thank you.